Welcome to lesson 13. In this lesson I want to show you how to set up a new drawer style in the Analyzer script questionnaire. For that we go to User Settings, the Script Setup, and here you can see there's different drawer styles. That's where for instance, our tandem drawers are set up. All the parameters that it shows in the data sheet, they will be filled in here in this table here. But first I want to show you how to change a drawer style in Analyzer CAD.
Yeah!
We start with a drawer box here. The base cabinets. Let's select the 4-drawer drawer unit. We insert our dynamic block. Let's make it a bit wider. Let's say 500. And then create a 3D. By default, they're Bloom tandem box drawers, but in this case I want to show you how to set up a legra box, because the legra box got a rebate on the bottom, so that's an additional feature that I want to show you in the Analyzer questionnaire. The quickest way to do this is to delete all the drawer boxes, and I've set up a couple of blocks for legra box that I have in my tool palette, and I want to show you how to insert them. Get rid of those grain lines as well. So in my tool palette I have set up a couple of blocks for my legra boxes. In this case we want to use legra box K. We select that and we set it into the midpoint of the back edge of the drawer front. That's my insertion point. So that butts it nice into the drawer front. Now the width obviously is slightly different. Now in the Bloom specification, the width of the drawer bottom is 35 mm less than the internal width of the cabinet, and the back is 38 mm. So we need to adjust those values here. So what I do is I click on the bottom. That shows me the internal width of the bottom. In this case it's specified as length, so that's the 464 mm. So I need to deduct 35 mm from that. I can use the calculator for this. 464 minus 35, that's 429. So how I do this is I click on the bottom here, go into Properties, and I enter the new value of 429. So that automatically extends my drawer width to both sides. Now I also need to adjust the grain line. So I delete the grain line. I'll go into Analyzer Part Properties. Select the new grain line. I readjust this. That's important. Save it. Now I need to do the back as well. That one is 464 minus 38. So that's 426. So my drawer is set now. The only thing I need to do is change the assembly. So I select the two parts, Part Properties, set Select Next, and I select my assembly of my cupboard. And I set all. So all I need to do now is copy them upwards. Select the whole lot, including grain line at the back. my start point is the midpoint of that drawer front. Go to the next midpoint. Next one up here. And the last one. So all my drawers are done. The only thing I need to do is change my part type for the drawer fronts. They're still set up as tandem box. So I select my bottom here. I select all the drawer fronts. I use the bottom as a reference, so I don't need to type it in. I can just copy it across. I've got my 4 drawer fronts, the drawer bottom. I'll go to Analyzer CAD part properties. So this is my drawer bottom. I keep this legra K part type. Set it as next, and I set all, so that'll put it onto my drawer fronts. So now we can see what happens when I put it into Analyzer Manufacturing. Here on our geometry script. Now, since we don't have the legra box K set up in our grip questionnaire, it doesn't show any drawers here. Now to set up our legra drawer box, we need to get up into Analyzer Questionnaire. So we go to User Settings, we select Script Setup. So what I do is I put that to one side. And I bring this across. And then I've got my Bloom data sheet here. And I select the new drawer here. I've got drawer style 8 available. And I need to put my part type name. I call it legra K. Now I entered legra K because that's the part type that we use in our part properties in Analyzer CAD. Now the first table is the drawer front drillings. Everything is based on the bottom face of the drawer bottom. So for the front drilling, we can see that here. It's got a 51mm up the first hole and 14mm in from the inside face of the cabinet. Now to actually get the measurement from the bottom, you have to do a small calculation. So 51mm, we use the calculator again. 51 minus the 23.4 gives me my 27.6. Now since our drawer front is turned by 90 degrees, we need to use our X offset for this number. So we use the X offset of 27.6. Now the Y offset, that's our distance in from the side. We have 40mm in from the edge of the cabinet inside. Our drawer bottom is 35mm smaller overall, so that's 17.5. So we got 17.5 minus the 14, that gives us 3.5 from that's the measurement from the edge of the side edge of the bottom of our drawer bottom. 3.5. So it's a 10mm diameter there. And the depth, minimum 12mm as it says here. It's 12. The drill type is a number 10 drill type. That's our standard drill. Now the next hole, it's 32mm up, so it's 27.6 plus 32. That's 59.6. And the Y offset is 3.5. Again, it's a 10mm drill, 12 deep, and the drill type is 10. That concludes our front drilling. Now let's start the end drilling here. For that we need all the sizes listed in this area here. So first we need to specify the diameter of our drill bit. It's usually a 5 millimeter. The depth is 12. Tool type is 10. And here is the first row distance. Again, that's from the drawer bottom under face. So we got the 38 millimeter there. And there is a 23.4 millimeter difference there. So our size here is 14.6 millimeter. And we don't worry about the second row distance. It doesn't have one in this case. Now, according to the depth of your drawer, you need to set up a drawer depth. So we're going to use this value here, the upper value here for 350, because all the drillings are the same for those. So we enter 350 here. And this one now is the distance in from the front. That's the Y distance here. So if we look at our cabinet end, it's flat, so that will be our Y distance here. Let's bring this up again. So this is our Y distance here. As for my drawer runners, I prefer to have a fixing at the very front edge of the cabinet. So I want to use the hole, that's the very first one here. So that's 37 mil minus 2 times 9. So that will end up at 19 millimeter from the front edge. And the next one, I'm going to use my 37 mil hole there. And then do the next one is 32 mil up, so that ends up at 69. So I have 3 very strong fixing right at the front. Then I have one more at 192 plus 37, so that's 229. The last one is at 261. Then my next cutoff level is 500. So again I have my 19, my 37, 69. Then here I space it out a little bit. I'm going to use the next hole there, which is at 261. Then I use one at the very end of the drawer runner, which is at 293. Then there is a different drilling for the 600 millimeter and the 550s. So my cutoff level is 600. 19. Those 3 strong ones at the front. Then the 261, and the very last one at the back is at 357. So that's for my end drillings, and it takes care of all those 3 different levels of length there. Our next table is our back drilling. So our back drilling is relatively simple. It's 90 millimeter in from the side. So because the drawer back is turned 90 degrees in analyzer manufacturing, this is going to be our X offset. So that's 9 millimeter. The Y offset is 19 millimeter from the bottom. The diameter is 5 millimeter drill bit. And we go in now at 12 mil, and the drill type again is at 10. And the next hole, again 9 millimeter. The Y offset here is 19 plus 32, so that's 51. Diameter is 5. 12 depth. Tool type 10, and our third hole 9 plus 32 millimeter is 83. 5, 12 and 10. Last table is our drawer bottom. So that one is a little bit more involved in that because you want to do a rebate as well for the legra box. So the drilling here is 48.5 from the side and 24, but actually it doesn't show on the specification. There are more holes. So again, our diameter is 5 millimeter. The depth is 12. Tool type is 10. And the X offset, that's our 48.5 millimeter. Now the Blum documentation is slightly vague here. It actually, the drawer depth changes differently to the drawer runner side drilling. So it's actually changing at 300, and it changes again at 450, and then up to 600. So up to 300 we have a 24 distance from the front and 128, just 2 holes. So that's 24 here. The next hole is 152. Then up to 450 we got 24 again, the 152, 257. And with 600 it's 24, 152, 257, 397. So that concludes our drillings. Now we want to set up this rebate here. So the rebate is 38 wide and 8 millimeter deep. So we specify here that we want to add a rebate. We set that to true. Tool number, in our instance, is 6. And the diameter is 10. You can do that whichever tool you want to use. You can use a 12 millimeter. It'll give you a different tool path. The rebate width, that's important now. That's 38. And what I found with the rebate depth, it tells you 8 millimeter, but usually the boards they vary a little bit, so we usually use 16.3 for our specification because that's the maximum size that the board thickness usually is. So we need to, because you want to leave an 8 millimeter there, so you make that rebate a little bit bigger. And also found out that 8 millimeter is pretty tight, so this a good value here is if you use 16.3 for your board, to put 8.7 millimeter there. Gives you an extra 0.4 millimeter for your drawer runner. So we save this. We need to reload our drawing again, so we exit Analyze and Manufacturing. We don't want to save the changes. Go back to AutoCAD. We import our drawing cabinet again. Set up our job number here. Make it work code of 14. We run our geometry script. As you can see, it's been drilled according to the legra box K specification. Here are our end drillings, front drillings here, and the back, the three holes for the back. And when you look at the drawer bottom, you will see there's a machine block for our rebate and the drillings. So that's basically how to set up a new drawer style in Analyzer Manufacturing.
Yeah!
So now we can quickly export this to Analyzer CAM. We run the translator script. To Analyzer CAM. Select our work order number 14. We're just basically interested in the 16mm internal. So that's all our back and drawer bottoms. Just let's see how they've been drilled. Select the point here. We optimize our nesting. We can see our drawer back drillings, and here is our machine blocks, our rebates here. They've been cut as a pocket here. And that basically concludes lesson 13.